Okay, today we're going to be working on another way to write equations. This is called function notation, and we use function notation in several different scenarios. One, we could have an equation that we want to try maybe 3 or 4 different inputs. Function notation makes it very easy to see which input you're using. Another reason that you could use function notation is we may have several inputs we want to use and several different equations we want to try them in. So function notation lets us learn how to give different names to each of our equations. So in the old way, when we just use an equation, it's y equals mx plus b. For function notation, though, we're going to be replacing our y. That's our output. And instead, we're going to give it the name of our function. In this case, I'm going to call it f. And we're going to give it whatever input number. So we call this f of x. Or if it was named g of x. This whole thing, this f of x, replaces my y. So this whole f of x is my output. But it gives me a lot more information. It gives me a name for my function, and it gives me what value for x I'm going to be using. So what I'm going to have you do on number 1, 2, and 3 is change them into function notation from an equation form. And I'd like to ask you or challenge you to not just use f as the name of your function. Pick other names for your function other than f. Pause your video to do it, then check back for the explanation. Okay, so hopefully that wasn't too difficult. You should not have the same names for your functions as I have unless it's just an absolute miracle. But whatever letters you named it are just fine. So now we're actually going to practice using function notation. So to actually experiment with why do we need this other kind of notation. So when we're looking at number 4, they've given us a function named f. So they're saying in our function, we want to try 2 different x values. We want to try an input of positive 2 and get an answer, and then we want to try it again with an input of negative 2. So I'm going to do the first one with you. So we want to do f of positive 2 equals. So our output for function f, when we use positive 2 as our x. So let's go ahead and just do this. Negative 4, but instead of x, I'm going to plug in a 2. Plus 7. Okay, so my output, my y equals negative 4 times 2 is negative 8 plus 7. So my output, my y, equals negative 1 when my x equals 2. So I can write that as an ordered pair. I'm going to go ahead and do my ordered pair. It's actually over here. So my output of function f, when my x is a positive 2, my output is negative 1. And my ordered pair is 2, negative 1. That's how function notation works. So now I'm going to have you do the entire function again, this time using an input of negative 2, and write your ordered pair over to the right-hand side. So pause your video to do it, and then check back to make sure you did it correctly. Okay, hopefully you had no problem with that. Number 5, they're only going to have you evaluate the function one time. They're wanting you to evaluate function f with an input, an x value of negative 3. The only warning I'm going to give you is when you're substituting in for x, use parentheses. That negative 3 goes in parentheses, otherwise you'll screw up the squaring of the negative 3. So solve number 5 and write your ordered pair over on the right. Pause your video and then check back for the solution and the explanation. Okay, as long as you were able to square your negative 3 correctly, which negative times negative becomes positive, and you got your 6 as a negative, then I'm sure you got this one correct. All right, so let's look at the last 3. The last 3, they're giving us some information. They're wanting a function of f where our input, T this time instead of x, is the outside temperature, however many hours after 6 a.m. So what we're doing is explaining the meaning of each one of these statements. So if we look at number 6, we're saying we want to know the outside temperature, which is 58. So our outside temperature is 0 hours after 6 a.m. So what that means is at 6 a.m., it is 58 degrees outside. And if I had to write that as an ordered pair, I would say 0 is my input and 58 is my output. So I want you to pause the video and see if you can figure out what the meaning is. Number 8 does not have an ordered pair. It just wants to know what the meaning is for number 7 and number 8, and then turn the video back on and check the explanation. Okay, so as long as you were able to know that 6 hours after 6 a.m. is noon, and 3 hours after 6 a.m. is 9 a.m., 9 hours after 6 a.m. is 3 p.m. So as long as you were able to convert your hours, I'm sure you did fine on this. The other thing is I did fill in what do we know. And we know that our input is t. That's the time after 6 a.m. And our output is the result, the function of t, f of t.